Welcome, welcome, welcome. It's Blades here. It's where are we up to? Number 7. Wow. C++ programming design patterns. Wow. We've actually arrived at the good bits. Let's explore. Here we go. What have we done? What have we done? Let's just have a look at our program, eh? Look at all of this mess here. So we know it works, but even me editor's complaining about it. Look at this. Init module 2. What's all this rubbish about? Right, let's just clean it all up because we don't want this here. All of this can go now. That was all practice and pretend and stuff like that. So what we're going to do with our server, under source, under networks, which we now can rename to networks underscore module 2. You notice I'm keeping them in modules. I'm keeping everything separate. That's on purpose. Design patterns maybe. No, it just makes it easier for me to work with, that's all. In here, what kind of header do I want? Let's call it a new folder, server. Sounds okay, doesn't it? Yeah, server. And in here we'll have a new header file, new file, and we'll just call it TestServer. There we go, .h this time. Don't forget the .h, because look what happened to us last time. Yeah, we've got module. Module 2 can move into there. Yes, move it please. Thank you. That puts module 2 there, and we can now rename that to module2.h. Now, I think I made a mistake in there so that we couldn't see it. Does it come up as a mistake? Yes, it does. There you go. Printf doesn't exist. We never knew about it because we didn't have it in a header file and we didn't have our IntelliSense going. But this file should include stdio.h, which is a C header file from the C language, which gives us printf. I hope. Thank you. So yeah, we had made a possible bug there. It could have stopped working and we would never have known why because, well, we'd never really looked at it. So there we go, there's module.h. TestServer is going to be easy. That comes from our CPP. And it's just namespace module 2 with everything else. Don't need anything else from there. Did I use IOStream? Well, we'll soon find out anyway, won't we? So it's 11. It's everything. Oh, I put C string there, you see? I did it this time. And it's everything down to, yeah, namespace is already in. So it's everything down to there, and we just cut it. And we pop it in here. There we go. And that's it. Hash include them two. I don't know why they go squiggly. God knows why. I'm not really bothered because I'm not going to be using this. Oh yes I am. But there we go, it's come back now. It remembers now. Good grief. So let's have a look what we got left here. A couple of includes which we'll get rid of. Okay. So module 1 strings. Oh yes, module 1 strings. Yes. That should be in the strings module. Where's our strings module gone? There it is. Cancel because I couldn't tell what I did. Module 1 strings. Move rename to module1.h. Right, so the idea is that you include a module and that will do everything for you. Module 2 does a little bit more than I want, well that's fine. Module 1 does the correct thing. It includes that. Split string.h, yep, that's all we've got. Module 2 should include the test server, really. But I'm not going to do that because all of this could move very, very easily now. It's in wide open space as well. That's fine. That's fine. I'll leave it as it is. I'm not going to touch the code. Doing that on purpose because I want to touch the code later. This brings me on to exactly what is well, program design patterns, doesn't it really? Because now what we've got is just a bunch of stuff and we've moved it. And that means our .profile is completely wrong, doesn't it? So sources, header files, we now have strings module 1 split string.h. Well, source module 1 isn't there anymore. So I just want to cut you out. And we'll put you here. Because you're now in strings underscore module 1. And you've now got a .h. And we should have a continuation there as well, if we are going to be sensible about it. So that takes module 1 out of the thing, doesn't it? Out of our way. So module 1 is out of the way now. Module 2 is a bit more complicated. Module 2 means I now have module 1 CPP there. Now what we can do is that, and it's now source / and it's going to be networks. Have I done that plural? Yeah. Module 2 / and let's see, what do we want first? We want module 2.h. There we go, that's that. And we also need TestServer.h, don't we? So that will be source / networks / server, and then it's just TestServer.h. There we go. I think that's all the .h's we have there. Have we got any .cpp's? No, we haven't, have we? We haven't got that far with this. Yeah. Again, I haven't made well, have I made a class? We're close to it. We are very close to it. But yeah, we need to be able to start thinking about making a class. The problem is, how is our class going to look? Because this is not exactly what we want a server to do. We don't just want it to start up and the first client that comes along closes it down. That's not really how servers work. So we want it to be able to start up and then it will close down if something is an error or the administrator needs to close it down to do an update or something. Yeah, I think that's simple enough. So server can close now. I've got module 2.h. Everything's groovy. Network module 2. Right, I can close that down now. Fantastic. C++. Oh, wait a minute. We've altered this, haven't we? Yeah. If I've made any mistakes, I do apologise. My eyes aren't working at this time of the day. I've got 2 CPP files so far. Wow. No classes at all. So there's no object-orientated programming going on here. And that's the first thing I have to mention. Object-orientated programming. That is a design pattern that was introduced with C++, where classes are treated as objects. And each object has its own data, and each object can either, stores data and can do functional implementations or methods upon that data, should you wish to. That's what a class is. It's just an object. In Qt, it takes it one step further, and they actually have Q_object macro, which then plugs it into an application, a Q application, and everything can talk to each other. That's nice. That is a brilliant system. So Qt already has a design pattern built into it with the Q_object and object-oriented programming, because that all boils down to an event system within Qt, and you can also design your own event style things on top of that using the QObject macro, so that classes can respond to events or calls from other classes, or whatever you want to do, really. Mighty fine coffee here. So that's the first part. Going with Qt aside, let's have a look at program design, shall we? Here we go. So let's explore 7. Programming versus language. Programming is nothing to do with language, and language has nothing to do with programming. Programming can be done in English, and that's the language of choice I use, for my programming anyway. The language is interchangeable. You can do all of this in any language and it all works. Because what this is people's experiences in the past. So people have been programming, they've swapped ideas with other people, then people have noticed that that program would also suit the behaviour of something else, and etc, etc, and out of all of that, design patterns have emerged. And there's a few here, highlighting the adapter. Convert the interface of a class into an interface for the client, often called a wrapper or translator. Well, we've already done that for string, nearly. So adapter, the design for that, the design pattern for that can be used on module 1. Because module 1 extends the standard library string and gives it the ability to split a string, which the standard library can't do. Which is a bit weird if you're using Java or something like that, because you can do that. But in C++ you can't. It's not automatic. You have to write your own. So that's why I did. That's why I use that as a proof of concept here. This will probably become a proof of concept for an adapter. Whereas module 2, I've totally highlighted, I've starred it, the command, encapsulate a request as an object. Yeah, that's basically what it means. This is prime candidate number 1 is our module 2 for the command design, which is possibly one of the more complicated ones, which is why I've chosen that one. It's also the most fun to do, because once it's done, oh god, it makes your life easy. Because once you've done it once, it becomes easy to understand, and when you've got it all working for the first time, like I did, when I got it first working, it was a joy of joys. I've now got a command design working. Wow! and I've done it without any callbacks. Yeah, so it was quite pleasing to say the least, and I think I will share that with you. I'll convert it into Networks Module 2, and then we can see how. And then it'll be obvious to see the implementation of it and how powerful it's going to be in the future. What we're going to do is we're going to do a proof of concept first. This is all about proof of concepts. When I'm programming, the first thing I do is a proof of concept. Some people hate this and say, no, you should do tests, test-driven development. Yes, you should, is the answer. I will not argue with them one little bit. You should do test-driven development. I totally agree. It's the safest way of doing things, but it's only as good as your tests. So I do proof of concept, which is only as good as my concept. And if things look messy, I have design patterns to fall back on. I have my own experience to fall back on. I have anything else that I've written to fall back on. My God, this web page is full of my programming. God, there's tons of programs to fall back on. Just slot them in, because they're all transferable. They're all cross-platform, so you can just slot them in. That's the idea of working in C++. You develop programs and systems which are transferable, and after a while you start building programs out of what you've already written. Yeah, that saves time, doesn't it? Yup. And if you've got a good design pattern working for you, it also makes it very easy to change things and update things and tailor things to your needs. That's what design patterns are about. They're about people who have, through experience, created a pattern or a design that will solve a problem and is transferable from the problem in one case to the same kind of problem in another case. For instance, the command pattern, when you see me do it, you'll instantly recognize, or hopefully that you'll instantly recognize, oh my God, that would be brilliant for a graphical user interface for the user, because it is. I think you can also build event systems around it, because event systems work in a similar way, which is why I keep looking at Qt and thinking, maybe that's what they meant. But it's always hard to tell. It's always hard to tell unless you're told. So if somebody was to phone you up and say, I don't understand what you've done with this program, and you turn around and say, oh, I use a command design pattern, and if they know what the command design pattern is, they can go, oh yeah, walk away and carry on. Whereas if you didn't use a command design pattern, you've got to then go into a conversation about which bit don't you understand, and then you've got to confirm to them or expand upon your thoughts when you wrote it. God knows how long ago you wrote it and whether you can remember. Yeah. You can see advantages of design programs. Now, the disadvantages of the command program is it could explode in your face, in the fact that it creates files galore, just due to its nature. For each command there is a file. So yeah, if you've got 1,000 commands, you've got 1,000 files. You wouldn't use it in that situation, I hope. You would probably use something different. But the whole point is it's transferable, and for smaller structures, say for a network interface or a graphical user interface, it's perfect. Absolutely perfect. So yeah, those are the kind of situations you use it in. You could also use it, I suppose, for a language. So you had 63 commands. Oh, that's C++, isn't it? Yeah. Makes you think, doesn't it? So in the next lovely installment, now we've got our stuff cleaned up, we are going to write a command design. A very simplistic one. And then we're going to expand it, obviously. Maybe in the same thing, but I don't know yet. Let's see, what have I added here? I don't want that file, thank you. I'll pop you in there. Right, have I ignored anything on this sheet that I made out on program design? So it goes down. What should we do? Refactor. Well, that's what we've just been doing. Refactor means move things around and stop the squigglies and things like that. Stop the stupidity happening. So all I've done is I've stashed everything away into the correct places. That's all I've done. Just move stuff around. So no, I haven't ignored anything. There's plenty of these. There's plenty more of these as well. There's about another, a good, at least 50 more plus any that you could think of yourself. You can write your own designs. Why not? You know, that's what they're for. So you could sit down and say, oh, I want to use this design pattern. You've seen me do it. You've seen me write out, well, in the past, I've brought in like a picture and said this is how it's going to work, and said this is the pattern that I want to use, or design that I want to use. That's a design pattern. The only difference is I wrote it. Just because it's not one of the standard ones that have already been pre-published and people write books on and earn money. Yeah, I should think about that one day. Yeah. You can earn money just writing books on design, program design patterns. There you go. Wouldn't that be ace? So that's me get ignored on. That means I can now... Yeah, we deleted all those, moved them. Yep. Okay, we can plus that up. And this is explore #7. Wow. Where did all that exploring go, eh? And that's colon C ++ programming design patterns. So we already know what we're doing next. Full stop. There we go. We can tick that, please, and send that on its merry way. We're all done. That's saved out to my server. I hope. Clunk. Yep, that's done. So I hope that you're happy that I haven't done much programming in this and just cleaned it up, because now we've got a dev area. We can do a design. We'll use module 2. So really we're just going to start off with module 2 and do a design pattern. Alright, undo that. It doesn't undo in here properly. Oh well, never mind. That's because it hasn't saved out. Don't save. So yeah, it's just me fiddling about it. I automatically do it. I shouldn't. That's it. Catch you in the next episode with the command design, and in the meantime, take care, explore and have fun.